We've talked about the importance of solutions, how we measure their concentration, how we can think about preparing solutions. Now we want to talk about the idea of dilution. So functionally, the most common way we prepare solutions in the lab is through dilution, where you take a small amount of concentrated solution, you make a larger volume of solution by adding water to it, and therefore lowering the concentration. This is really common because generally if you buy chemicals, it's generally more safer to buy like a solution of chemical, especially something that's really reactive, as opposed to pure acid, like solid sulfuric acid you don't want to be messing with. So you buy a really high concentration of it, and then we don't use that super high concentration in the lab, but we dilute it out to a lower, safer concentration that has a larger volume that, those are the kind of things that we would use in the laboratory setting, where it's much more reasonable and much safer. So when we're doing dilution, all we are doing is taking a small volume of concentrated solution, so lots of dissolved solute, and we add water. That is a solvent, right? So all we're doing is getting to a higher volume by adding more solvent, leading to a lower concentration. So whenever you are doing dilution, you can only generate a larger volume with a lower concentration. That is always going to be the case. You'll note one of the impacts of it in this cartoon is that we started with a small volume of like darker orange solution, and we end up with a much lighter color because there are the same number of molecules that are dissolved. You have the same exact number of solute molecules. They're just spread over a larger volume, so it's a less intense color. So basically all of the properties get functionally diluted. Right? The color is diluted because it's less intense. The reactivity would go down because it's diluted, it's less intense. All of those properties would be decreased. Since we use dilution so much, we want to be able to use it effectively and efficiently, not just haphazardly add water, but quantitatively predict how we should actually go about making a diluted solution. What sort of volume of concentrated solution should we start with? How much should we be adding in? What should we be looking to get to? And we're going to rely on the fact that the number of moles of solute, the number of solute molecules, doesn't change. You only add solvent, usually water in all of our practical cases. So because that number of moles of solute is constant, that is equal to the molarity, or the concentration, times the volume. That never changes. So we can use the overall equation, M1 times V1 is equal to M2 times V2, where these M's represent molarity and the V's represent volume. Okay, so basically you have your state 1, this would be your concentrated initial solution, and then your state 2, which is your larger volume diluted solution, so lower concentration. So the M's are both molarities, the V's are both volumes, so we use those subscripts 1 and 2 to denote that that is either pre or post dilution. Let's look at an example. We are given a 12.0 molar HCl solution and want to prepare 300 milliliters of a 0.600 molar solution. How would we prepare it? As always, we're going to start by asking, what do we want? And what we're actually after here is a recipe. We want to know how would we prepare the solution, right? So this is actually we want to be in the lab providing guidance. You're going to write some instructions for how to prepare this solution. And in general, there are going to be 2 ways to prepare a solution. Either take some solid, dissolve it in some solution, or you do a dilution. Okay, so if you only have a single solution description, right? You think about that very first problem for computing the molarity of, say, you dissolve some H2SO4 in a solution of water. Do your conversions, combine them in the molarity equation, just use that molarity equation. But here we can see it's different. There are 2 solution descriptions. I've got a molarity of an HCl solution, and I have a molarity of a HCl solution. These are 2 solution descriptions. There's no amount, there's no mass, no moles of anything, just 2 solutions. And that's a sign we're doing dilution. And so we want to give instructions related to how to do a dilution. which means how much of the concentrated solution do you start with and how much water do you add to it. We want to use, in order to figure that out, we're going to use our dilution equation. M1 times V1 is equal to M2 times V2. When it comes to dilution, we always have an equation that we can work through, which means we can ask what sort of variables do we have for that equation. And in general in dilution, lots of numbers are given. We have 12 molar, we have 300 milliliters, and we have 0.6 molar. When we're working through these, we want to try to figure out how are they paired together. So one of the things we can see is that it's 300 milliliters of a 0.6 molar solution. Those two values describe the same solution, either pre or post dilution. What that means is they're going to have the same subscripts, either the 1s or the 2s. Okay? And how we can figure out which one is which is it the pre-dilution concentration, which is high, or the post-dilution concentration, which should be lower. 0.6 is less than 12, which means this is number 2. Then that implies that this 12 molar, because it's the other concentration, has to be the different number. That has to be 1, right? So that is going to be solution 1. What we can then see, we have molarity 1 is the 12.0 molar, 300 milliliters is going to be that final diluted volume, and 0.6 molar is the final diluted concentration. And in fact, this is when you're trying to come up with how to create a solution, this is what you commonly have. You are given specifications. I have a target volume and a target concentration. You are given some concentrated solution. How do you do the dilution? How much of the concentrated solution do you start with? And then you add some water to it. And that how much of the concentrated solution is going to be V1. This allows us to solve for V1, which gives us the recipe for the dilution. Measure out some amount of the 12 molar concentrated solution, then do a dilution. Add some water to it. So let's actually work it out, see how it goes. We're given a 12.0 molar HCl solution and want to prepare 300 milliliters of a 0.600 molar solution. How would we prepare? So we can see here that we're dealing with, I'm asking for a recipe. How are you going to prepare this solution? And when we're thinking about that, what we really can key in on is the fact that we have descriptions of 2 different solutions. I got 2 molarities that are given right there. Means I'm dealing with 2 different solutions, which means this is a dilution problem. I'm going to take my more concentrated solution, I'm going to add some water to it, and I'm going to end up with a larger volume of a lower concentration solution. Whenever we're dealing with dilution, the equation that we're going to use is M1 times V1 is equal to M2 times V2. And so it's just going to be a matter of figuring out what all we have, right? We're given 1, 2, 3 numbers, and which variables do each of those numbers correspond to? Okay. So one thing we know right away is that these M's are going to be molarities, and this milliliter is going to be one of these volumes. We can see that these are paired up together, right? 300 milliliters of a 0.6 molar solution. So that's either this pair or this pair, but they describe the same solution. And so we can figure out which one by seeing those subscripts. It's either going to be solution 1, i.e. pre-dilution, or solution 2, post-dilution, after we've added water. So the way we can tell is that it's a lower concentration. 0.6 molar, we started at 12. So M2 is going to be this 0.6 molar, and the V2 is going to be 300 milliliters. That means this 12 molar is going to be my M1. That leaves V1 as an unknown, which actually makes sense because we're trying to figure out how to make our target solution. So 2, the second solution, is always going to be our target. So that's something where we know what it is. We know what the concentrated solution that we're starting with is. So the question is, how much of it do we need to start with in order to do our target dilution, or our goal, reach our goal for dilution? So let's go ahead and substitute those numbers in.
12.0 molar times V1 is equal to 0.6 molar times 300 milliliters. So I can rearrange, divide out my 12. I get 0.6 molar times 300 milliliters divided by 12 molar. So one thing to note here when you're dealing with a dilution problem, it doesn't actually matter that our volume is in milliliters. You know, normally when we work with molarity, we need to have everything in liters, but it actually doesn't matter here. The milliliters are fine. What is necessary is that our concentration unit types match. These both need to be molarity, so that way at this step, they cancel out. This is left with milliliters, that's fine. It does mean this volume is going to be milliliters. So if you had two different volumes that were given, you would need to make sure that those two volumes did match up and that they were the same. But we can go ahead and do our arithmetic, and we end up that V1 is equal to 15.0 milliliters. Sorry, I dropped some of the sig figs on S6. It should be 3 sig figs based on all of our input numbers. I just looks like I got a little lazy in writing those out. Sorry about that. All right, so V1 is 15 milliliters. So we're close. We haven't come up with how would we prepare this solution. We have the numbers that are going to go in, but we need to actually write out a recipe. We need to write some instructions. All right, so V1 is 15. That pairs up with your M1. So our procedure is going to be first, measure out 15.0 milliliters of the 12.0 molar HCl solution. Step 1. So, that's good. That's step 1. That's what you could tell someone. Measure out 15 milliliters. So you've started with your concentrated solution. Now it's time to dilute. So we're going to say add enough water to reach a final volume of 300 milliliters. And you can see we use this very, very fun word, enough. We don't even actually say how much water to add. We just say you need enough water. You need a total volume of your target solution, right? Molarity, if you think the denominator in the molarity equation is the volume of solution. We don't care about how much there actually is, how much water you add. And actually, you really can't figure it out using this. So 300 minus 15 would be 285. So you're probably going to add about 285 milliliters of solution. But liquids don't necessarily, volume is not additive. There's, this 15 milliliters isn't pure water. There is a bunch of HCl in there. That's going to affect how volumes actually add. Only masses are additive. So we don't actually, it's not going to be exactly 285. It'll be close. It may be actually like it's probably actually more like 284, actually probably more. So you probably have like 287 milliliters because basically the molecules end up contracting, they get closer together. But you're going to end up with 300 milliliters total. And that's really all that matters is that total volume in the end. So whenever we're dealing with dilution, whenever we are given multiple descriptions of solutions, we know we're dealing with dilution. We have our dilution equation. There's a lot of variables, usually dilution. That's why there's a lot of information in the prompt or in the question or in the situation that you're actually dealing with in lab. You got a lot of numbers, put them in your dilution equation. And then once you get them in there, generally it's fairly kind of robust. It should hopefully make sense. And then this is the actual process. One way you can check your results is if you look here, your V1 is 15. That is your pre-dilution value. You're saying you have 15 milliliters and you're turning it into 300, which has a lower concentration. That's good. One of the ways you can check your work, if for V1, you got a volume that was larger than 300, that implies that you made a mistake somehow. that somewhere there was an issue in how you went about solving this, because you were saying you started with a higher volume of solution, you added water and ended up with a lower volume. So you decreased the volume of solution by adding water, which is impossible. So that is unlikely. Now, but 15 is much lower than 300, implying that when you're diluting, you get to a higher volume, which makes sense. So that's consistent. If you had gotten a number above 300, that would be an issue. But otherwise, that's how we do dilution. We'll see it come up in lab. We'll work through it. I'll get some more practice. Dilution is a big, big part of chemistry and something we definitely want to be comfortable working through. Definitely something we should expect to see again, especially on, like, say, the test. But otherwise, yeah, so there we go.
Participation 6-9, question 3. You have 75 milliliters of aqueous sugar solution. You add enough water to obtain 0.55 liters of 0.26 molar solution. What was the initial concentration? This is the third question on participation 6-9, due Tuesday, June 9th at 11:59 p.m. over on Blackboard. Link to the assignment is right below the links to these videos. Again, you have 75 milliliters of aqueous sugar solution. You add enough water to obtain 0.55 liters of 0.26 molar solution. What was the initial concentration? All right, that's going to do it for chapter 3. Started with kind of just discussion of what a counting unit was. We looked at some kind of basic examples, defined the mole, applied a lot of the mole, and then this discussion of solutions and everything associated with that, especially molarity and dilution. So you want to be comfortable with that. Is a fair amount of computation associated with this chapter for us to kind of be comfortable with, a lot of computations using equations, that kind of stuff. Okay, 3 questions on participation 6-9. You want to find all 3 of those questions, get them answered, get those answers submitted over on Blackboard by Tuesday night. Depending on when you're watching this, Tuesday morning, identifying an unknown substance, pre-lab technique and notebook due beforehand. Otherwise, post-labs due Wednesday along with the Module 3 homework. On Thursday, we will have exam 1, so we'll meet at 9 a.m. in room 141, the classroom that we've used before. We will do the exam, and then after that, we'll do reactions of copper. Pre-lab and all that kind of stuff is still due at 9 a.m. the start of the day. You're not going to be doing them during the test. And then we will have the participation assignments for the second half of the week as well. Do want to note that the answers to the participation assignment will go live Tuesday night. If you have any questions about any material you want to meet before the test, happy to set up something like over WebEx, a video conference or something like that. Otherwise, that is going to do it for material on the test. I'll see you there. If you have any questions, let me know. Otherwise, enjoy the rest of your day. Bye-bye.